Hello and welcome back to another exciting Colovision or Turdford 67, whatever. Anyway, don't do drugs. Drugs are bad. Okay, now that we've got that stuff out of the way, here's a random little soldier. I'm gonna get you. No, never mind. I forgot what this video. All right, that's right. This video is on Lewis structures. So let's get into how to do this. I'm doing this video because I was looking on the internet and unfortunately nobody was doing a very good one. So basically what we're looking at is this, and you'll see this kind of stuff, and when you get into organic, you'll explain it more. But like a little bit of notes from class here, like ethane. What does ethane look like? Ethane looks like this, C-C, and then it's got 4 H's around it. Wow, that's so cool. H, 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 H. So that's what ethane looks like. 2 C's linked together and all these H's around it. This should say ethene over here. Ethene looks like this. It's got what we call a double bond between the 2 carbons. And we need to explain what this is before we get too far. And then we've got an H, and an H, and then we've got H, and then an H. And then the same thing in acetylene. Acetylene's kind of neat because acetylene has what's known as a triple bond between 2 carbons. So we need to explain what a triple bond is, but we'll do that in a second. H and H. So basically what you're learning how to do is how to draw these pictures. And this will probably take a while to run through. We'll run through quite a few examples in this video just to try and help you out and get you an idea of what it is we're doing. But we're going to teach you how to draw these. So really what we're doing, I don't know if any of you have ever played with any of like the little molecule kits before, like with water, but that's what you're learning. You're going to learn what the actual shape of the molecule looks like in these covalent bonds that you're seeing here. Now, to do this, the only thing I need you to understand is what these lines represent that you see me drawing. If you see me make a line, let's go back to carbon, and let's say there's a C like this, and you see me make a line beside it and connect it to another atom. Maybe we connect it to an H. That line means that they are sharing a pair of electrons. So literally, this line represents 2 electrons that are being shared between the carbon and the hydrogen atom. That's what that line represents. Now, the big thing I need you to remember is that most of the atoms on the periodic table need 8 valence electrons. Most of them need 8 valence electrons. Third drawer. Right. There. Yeah, behind the stock. Bam. Sorry, I was having somebody get me a periodic table. Thank you, lovely assistant. All right. So, anyway, we're going to need a periodic table here in a second. So I'm going to slide him up out of the way. But most of the atoms need 8 valence electrons. Now hydrogen does it because it's so small, all it's got is like a 1s2. But you're going to see me do something else. You're going to see me make a line like that. Every now and then you might see me make like in one of those. You might see 2 lines. That represents a double bond. That means they're sharing 2 pairs of electrons. So that represents 4 electrons that are being shared between those 2 carbon atoms over on this one. Other things you're going to see me make sometimes. Let's say I've got an O like this, that's a terminal O. That means it's hanging off of something. That means it's sharing a pair of electrons right there. This electron needs 8 valence electrons. So I'm going to come back and I'm going to put these electrons around it. So I've got 2, 4, 6, 8. Each one of these, this is what we call, when you see me do this, this is called a lone pair. Or some people would call it an unshared pair of electrons. Their electrons are not being shared. So now some people would do this same drawing. Instead of doing this, they would draw the line. They'd put an O, and they'd put 2 dots above, 2 dots here, and 2 dots below. I don't like doing it with the dots. Even though some people call these dot diagrams, I don't think they're very pretty looking. So I just do the method where I draw the line, and that represents a pair of electrons. So every time you see me draw one of these lines, I'm representing a lone pair of unshared electrons. They're just hanging out there. That's part of what you got. Now, we could go into a lot of detail on why these bonds occur the way they do. But let's go into actually drawing the diagrams, and that's what we want to do. Now, I've got a set of steps here, and I have no idea on the video if you can read these notes or not. But these are going to be my steps. Step number 1, I'm going to count all the valence electrons. And if you don't know how to do that, I'll show you a very quick way of doing that. Step number 2, I'm going to take the least electronegative atom and put it in the center of the molecule. I'll give you a couple of hints. H will never be in the center of a molecule. Hydrogen never will. I'll give you another hint. If you've got a carbon, that's going to be the center of your diagram. I mean, that's like guaranteed money in the bank. Step number 3, draw a tentative diagram. Join atoms with single bonds and add unshared electrons to complete octets. Remember, most atoms want 8 electrons. So in other words, if I'm drawing a picture and I've got something with a dash Cl on it, I'm going to come back around that Cl and I'm going to go 1, 2, and I'm going to draw 3 unshared pairs around it. So now it's got, check this out, 2, 4, 6, 8 electrons. I'm going to make sure everything has 8 electrons, unless it's something small like hydrogen or some of the little weird ones that do odd stuff. Anyway, step number 3 can make your drawing. I got you a few notes here. H is always terminal. What does that mean, H is always terminal? That means H is just always hanging off something like a dash H. It might be hanging off the bottom, dash H. Carbon should always have 4 bonds. What do I mean by that? Carbon should always have 4 bonds. I mean that carbon should always end up looking like carbon, and it might have 4 bonds like this. It might have a double this way, a double that way. Carbon might have a double and then a single. Carbon's always going to have 4 bonds. Basically what I'm saying is this. If you ever catch yourself making a drawing and you've got a carbon atom and that carbon atom and you find yourself with a lone pair, I'm not saying it's impossible to have a lone pair off a carbon, but it don't happen very daggum much. So if you catch yourself doing that, you better really check what you're doing, because there's a good chance you are doing the problem wrong. For the purpose, I think, of all like our 11th grade homework, I don't think there's any with a lone pair on the carbon. But anyway, and then if there's more than one carbon, make a chain. Make it balanced looking. I know that seems odd, but make it balanced looking. If you've got 4 hydrogens, maybe put 2 on one side and the other 2 on the other side. Make it balanced looking. So let's go through and let's do some examples of applying this. And the first one we're going to try and do an example of is CCl4. So we've got, here's going to be our compound, CCl4, and we're going to draw a Lewis structure of it. First thing I want to do is add up my valence electrons. To do that, I'm going to grab my periodic table. A very quick way of doing that is look at the Roman numerals at the top of the column. Carbon is in Roman numeral 4, so that means carbon has got 4 valence electrons. Now, chlorine is in, looks like it's in, chlorine's in family 7b. So chlorine has 7 valence electrons. It's got 1 opening in. That's why it's so dangerous. Now, 7 times, there's 4 chlorine, so 7 times 4. And again, this is our valence electrons, is all this is. We're adding up. So my valence electrons is what we're adding up across top. And that comes out to a total of 32. Now, a lot of people skip this first step. And what's bad is it's the only way you've got of checking your answer is doing these valence electrons. You don't add up these valence electrons. You've got no way to check your answers in these questions. All right. So now, step number 1 was to do this. So I got 32. Step number 2 is pick your center atom. Well, I've got a choice in this problem. C or Cl4, what's the center? Well, I told you in the notes, if you've got a C, pick it as the center. What if you didn't know any better, though? What if you weren't sure? Do your electronegativities, which in my periodic table, it's on the back. Carbon is I'm going to write this down right here off the side. Carbon is a 2.55 electronegativity. It means, is it going to take this electron away? Chlorine, on the other hand, chlorine is a 3.16. If you're in doubt on a center, pick the one that's the least beefy of the 2. Well, it's pretty clear. Carbon should be the least beefy, so carbon's going to be the center of what I'm about to do. So, step number 1, count valence electrons. Step number 2, pick a center. If in doubt, look up electronegativities. But if you got carbon, pick carbon. So I hereby declare carbon will go in the center of my picture. Now, Step 3, connect all the other atoms to it using single bonds. So there's a Cl. So I'm going to put dash Cl to the left, right. I know if you're watching this video, I just said left and right, but hey, I never said I've got to be able to do common sense. I'm going to put one down, and by the way, that's an extremely long bond I just drew. That is actually kind of odd and ugly looking, but anyway. And I'm going to put one more Cl up above it. Now, if you look at this, now I need to make sure that I've got octets. So I connected this up. I've got everything connected with a single bond. Now we'll make sure everything in the picture has 8 electrons. The carbon, 2, 4, 6, 8. It's got 8 electrons around it. Now, for these chlorines, I want to go back and add those lone pairs. Every one of these, I have to make them really bold so they show up. Every one of these needs 8 electrons. So I'm going to go back around it and make sure every one of these has 8 electrons. So each one of these bars represents a pair of electrons. So now you're asking, how can I tell if I did this question right? Easy. This is my structure. If I add up all the electrons in this structure, it should equal 32, which is what I had in the beginning. And sure enough, if you add all these up, 8, 8, 8, 8, 32, that means I have done this problem right. And if you want to know about geometry and all that stuff later, I can make another video on that. But this is not, I don't have any geometry in this. It's just how to make the drawings. Alright, so there you go. There's how we did the Lewis structure of CCl4. Let's go through and do a few more examples here. Let's see, what else can we do for an example? Let's see, next one. I've got some on paper, however, I'm not going to do all these on the paper. I'm going to do a few of them, though. I'll do, let's do NH3. Let's do ammonia, NH3. It's very common. NH3. So how do we do ammonia, NH3? Well, I'm going to grab my periodic table. I need to look up my valence electrons. Nitrogen is in family 5, so nitrogen has 5 valence electrons. Hydrogen is in family number 1, so it's got 1. However, I have 3 hydrogens, so 3 times 1 is 3. So I've got a total of valence electrons of 8 in this. By the way, a little hint, if you ever add this up and it's an odd number, you've done something wrong because electrons always come in pairs, so it's always got to be even. So, step number 1, add this up. Step number 2, pick the center between these two. Well, I can go and tell you, I gave you a little hint. H will never be the center. Therefore, by default, I'm going to write down the letter N as the center of my molecule. And now, step number 3 is attach everything with single bonds. Well, cool. I'm going to put a dash H to the right. I actually called it the right thing this time. A H to the left. And I could put an H on the top or the bottom. Where should I put it? Up, down, up, down. I like down. So I'm going to draw an H straight down. And now I need to make sure everything's got 8. Well, hydrogen doesn't need 8, so it's fine the way it is. But this nitrogen in the center, it needs 8. 2, 4, 6. So that means I'm going to take this missing spot and I'm going to put one of those free pairs up on top of the nitrogen. And now everything's got 8. And now I'll look at my picture and now I'm going to check my answer. I've got 2, 4, 6, 8 in the picture. I'll check my valence. It's 8. That means I've done this one right. Let's skip down and do another one. Starts getting long. Let's do ClF next. ClF. Chlorine and fluorine together. So ClF, if I look up my valence electrons, chlorine is in family 7 and fluorine is also in family 7. So both of these have 7 valence electrons, giving me a total of 14. Now, this is where you might be like, which one do I pick for a center? I've only got 2 elements. Yeah, I know. That's what makes it great. So I can just literally go Cl-F and put them together like this. And now I need to make sure everything's got 8. So I've got this single in the middle. Now I'm going to come back around this one. Free pair, free pair, free pair. Do the same thing to the F. Free pair, and a free pair. He's got 8. The fluorine's got 8. Now to check my answer. If I did this right, there should be 14 in this picture. Add it all up, I got 14. So that means I've done this one right. So your answer to this question is just that. Cl-F, single bond between them, 3 unshared pairs, 3 unshared pairs. And that's all there is to that one. All right, so I know what you're thinking. There's got to be some tricks. They can't all be just that easy, can they? Yeah, there's a couple of little tricks to look out for. Let's go with one like let's do this. Let's get another clean sheet of paper out here. Man, I'm dirtying up some paper today. Let's see what we can do here. Making the American timber industry very happy. Let's try this one. ClO -1. So what's going to be the significance of this negative on this one? We've got an ion here, a polyatomic ion here, hypochlorite. So what's the significance of this? Well, to begin with, let's not freak out. Chlorine, get your periodic table out. Chlorine's got 7. Oxygen's got 6 valence electrons. Now, right off the bat, I just told you a second ago, 7 and 6 is 13. I told you you cannot have an odd number. You know something's wrong. Wait a minute, this is 13 valence electrons. And it's a -1. Wait a second. -1 means it has an extra electron. It's negative. So 7, 6, and it's got an extra electron. So the total is 14. I hope you understand that. If it was -2, I'd throw 2 into the mix. -3, 3 extra electrons into the mix. And now I'm going to go back to what I did before. I'm going to write down Cl-O. There's not really a center here because there's only 2. And now I'm going to go back and I'm going to give everybody its 8 electrons. So everybody's getting their 8 electrons. And if we did this right, then there should be 14. And lo and behold, there's 14. Okay. So what about if you had a positive? In other words, what if it was like ammonium? NH4 with a +1 on there. So what would you do on that one if you had the +1? Well, we'll just come back in here. We'll draw down the N. Ooh, what am I forgetting to do? I'm jumping the gun. Gonna mess myself up. Let's go back and do our valence electrons. N is got 5. Hydrogen is 1 times 4, so it's got 4. So what is this total? 9? I don't think so. Look at this. That's 9, but look, it's a +1. That means it's gained or lost an electron. Positive means it has lost an electron. So instead of 9, this really only has 8 electrons. So that was important that we do that. Pick your center. I'm going to pick nitrogen. And now I'm going to connect everything with single bonds. 1, 2, 3, and 4. And make sure everything's got its 8. This has got 8 and the hydrogens are good. I've got 8. The answer's supposed to have 8. I've done this problem right, and that's the end of it. All right. You're driving me crazy. Is there something that could be a little bit harder? Yeah, okay, fine. You want a little harder? I'll give it a little harder. I know you might be watching this right now thinking, hey, this guy, he ain't got no game. Anybody can do this. They're probably teaching this in kindergartners in Poland right now. Well, guess what? Hey, well, anyway, I have no idea. The only reason I'm saying that is because one of my teachers in college, Dr. Jan Grako from Poland, he literally had us convinced in Poland where he come from, if you were in 3rd grade and couldn't do calculus, you were already not very smart. So anyway, I think he just liked to pick on us. But anyway, Dr. Grako, if you're watching this, still love you, guy. Anyway, so moving on. How about this one? HCO3 -1. Oh, you're going to burn this time. HCO3 -1. What in the world are we going to do this one? Well, let's start off by adding up our electrons. Hydrogen has 1. Carbon has 4. Oxygen has 6 times 3, which is 18. This is a -1, meaning we have an extra electron. So we've got 18, 22, 23. We've got a total of 24 valence electrons in this problem. So that's what I've got to work with. I need to pick a center. HCO, well, I'm going to pick C to be my center in this problem. Now, what most of you are going to do is now pick your center. Now you're going to attach everything with single bonds. I think most people that do this are going to do this. They're going to probably stick on that H, and then they're going to go dash O, dash O, dash O. Looking good so far. And then you're going to come back and you're going to give everything its electrons. Boom, boom, boom. Mr. Cole, this stuff is... Oh, no, I just gave out my real name on YouTube. Don't come find me. Anyway, look at all this stuff. Wow, this is too easy. What's going on? Actually, do your count. This is why I said the only way to know if you did it right is you got to count. If you add this up, it comes out to 26. And all of a sudden we realize for the first time we did not do this question right. So what do you do when you add them up and it doesn't come out? I come up exactly one pair over. What that tells me is this. Somewhere in this problem, I need one of these. I need an equal sign? No. I need a double bond. There needs to be a double bond in this problem. I'm not sure what to do, somebody says. Let's just go back to here. Let's not freak out over it. Let's just put our C down. Let's go back to here. And we need a double bond. Now, somebody might want to say, well, double bond to the H. You can't double bond to an H. H can only have 2 electrons, so the H is out. If you ever catch yourself double bonding an H, we got some issues. So what I'm going to do is I'm going to go back here. I'm going to pick one of these O's. And it could be any of these 3 O's. And this is why it's called resonance. You can pick any of these. I'm going to pick this one. I'm going to go down, double bond to that O. I'm going to put the one back on the left. I'm going to put the one back on the top. That part's no big deal. Now this is where somebody will want to be like, okay, now put the H back. I can't put the H back. Why can't you put the H back? How many electrons can carbon have around it? 2, 4, 6, 8. I can't put any more electrons around it. So the hydrogen's going to have to go somewhere else. Okay, let's put the hydrogen down here. No, I'm sorry. You're going to have to just learn something by taking more chemistry. Oxygen usually either makes single bonds or double bonds. Oxygen's not going to try and make that triple if it can help it. Let's take that hydrogen and let's just stick it over here. Oxygen likes a double bond, so we'll stick it over there. Now, we still need to make sure everybody's got their 8. The carbon does. This oxygen's got 2 and 4. So I'm going to put one below and one above, and that's got its 8. This oxygen down here has got 2, 4. I'm going to do something. 6, 8, and if you want to know why I put them at angles, well, you'll just have to watch more videos, I guess. But you could put them, depends on your teacher, you could have probably just put them like left and right. This one up here on the top, 2, 4, 6, there's my 8. I've got 8 valence electrons, and there's my picture. Could I have done the double bond up here? Yeah, I didn't have to double bond this one. I could have double bonded that one. I still could have got the right answer. Alright, I'm going to do maybe 1, 2 more, because this video is getting long already, and nobody's probably going to even watch it. But that's not my fault. Hey, if you quit watching this video now, my little ranger buddy's going to come. He's going to be like, I'm going to jump out of the sky, and I'm going to... It's hard to believe I'm actually supposed to be intelligent. Hello. Alright, sorry. Alright, back to it. Let's do one more maybe. I don't know. C2H2. Let's take a look at this. C2H2. Now, as we go to do this one, all I'm going to do is I'm going to go carbon. I'm going to do my count first. Stop. Don't not count. It's very important. Carbon's got 4 times 2. That's 8. Hydrogen's got hydrogen's got 1 valence times 2 is 2. Gives us a total of 10 in this. Well, I'm going to start out. If you've ever got carbon, it's going to be the center. And if you got 2 carbons, just do this. Make a chain out of it. And usually what y'all are going to do is this. Y'all would probably come back, put an H here, put an H here. And that looks kind of cool. I already told you at the beginning of the video what you're about to do is wrong. Most of you are going to now come back and do this. And when you do, you are incorrect. I told you at the beginning of the video, if you ever catch yourself putting 3 pairs on a carbon, you should get a bad feeling that something ain't right. Prove it. Count. 2, 4, 6, 8, 10, 12, 14 in a problem that's only supposed to have 10. Wait a minute. So we've actually got 2 pair too many. All right. When we had a pair too many, I added a double bond. But I've only got one place to even put a bond. So if I've got 2 pairs too many, instead of a double bond, what might I put? I'm going to put a triple bond in this one. So I'm going to go back to the 2 C's. I'm going to go right back to here. But now what I'm going to do is between these, I'm going to add a triple bond. And now look at my answer. This carbon's got 8. This carbon's got 8. And if we add it all up, it comes out exactly 10, as we've seen up here. All right, the very last one I'm going to do. And I know you're excited because this has been a really long video. Hey, it's long for me too. I have to sit here and do all this. Last one. Take a look at this one. C2H6O. Wow. C2H6O. Now, right off the bat, I wonder if you've got any ideas. How about this? Pause the video. Take your best shot at it. I don't want to ruin it for you. And see what you can do with it. No, I'm waiting. Well, if you're in doubt, see what you got here. Any ideas yet? Well, let's see. 4 times 2. Let's see, that's 8. And then we've got 6, and oxygen is 6. So we've got a total of, let's see here. Did I do this right? 12, yeah. We've got a total of 20 electrons. I don't know. I'm starting to get a little nervous here. What am I going to do with this? Pick a center. Well, you might pick C or you might pick O. This is what this problem has, an isomer. Iso means same. This means in this problem, you can have 2 answers. They're both right to this question. Both completely right. I'm going to do one by doing this. I'm just going to go C-C, and then I'm going to add this O onto the end of it. And now I'm going to fill in all these H's that are in here. So I'm going to go H, 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 H. And now if we look at the O, it needs some free pairs. And I'll be doggone. Is it really that easy? Yeah, it is. If you look, I've got my 20. What some people might have done trying to work this problem, they might want to put O in the dead center. Could we? Yeah, you could. If you put O in the center, you could put a C and a C on each side of it. Oh no, that's going to be terrible. Really? Well, take a look at it. You still got your 6 H's. Make it even looking. I don't know any other way to put it than that. Make it kind of balanced. 3 H's here, 3 H's here. My O doesn't have 8, so I'm going to come back, add a pair on the bottom, a pair on the top. And if you add this up, it's an isomer. It's got its 20. Both of these are exact right answers. This one up here is what we actually call ethyl. Well, I'm really terrible at spelling, by the way. But this is ethyl alcohol. You just can't see my E. And look, this is the exact same set of forming. Look at this. It's the same elements. All you've done is rearrange it. This is where organic chemistry gets to be such a big class. This one, though, on the other hand, this is what's known as an ether in organic chem. This is a completely different substance than this one. And both of them have the same set of elements in there. You arrange them different, you've got completely different formulas. Alright, well, I hope this video has actually been helpful. I'm actually sticking a fork in it, so to say, and I'm getting out of here. But anyway, you have a good day. Bye.